All right, well, here's a few news articles, might be interesting. So they've got an aircraft fueled by hydrogen. Some people have been talking about this every now and then for the last few decades as the next fueled cars and airplanes running on hydrogen. So apparently you do have a hydrogen-powered aircraft. So we'll see how well that works. I mean, one concern, of course, is the stuff is explosive, but of course, so is most fuel. So they may have found some way to cope with that. Putin seems to be in some trouble in Russia. So that is interesting because, as we know, he's controlling our politics here in America quite a lot, and especially meddling in our elections. And it might be nice if he was distracted by trouble at home, so he'd have less time to mess with us. Anyway, they're talking about the internal politics in Russia, and they're apparently talking about Third World War over there. So it does seem like they're trying to be distracted by a lot of fantasies over there from internal messages. I know there's got to be some trouble over Putin failing to poison his opponent recently. So this thing, Velociraptor, I saw it pushing, and I really have not tried it. I thought about writing projects to find out what it is. It seems a lot like it's Splunk. It's an open source project, and it measures what's going on in your endpoints, and they're talking about it. They've got a whole bunch of exciting people. Apparently, it helps you collect the data to see what's going on your network and respond to it. So it's an interesting idea. I certainly haven't heard of it until very recently, so I don't know how important it is to teach students yet. But it is open source, so we could get it and try it. So I'm not sure. I might try adding that to my instant response class, or maybe it's not worth it. I haven't quite decided yet. But it's out there, and you can install it on Ubuntu. And so might be worth checking out. Fortinet, of course, one of the main firewall vendors, and apparently there are 200,000 FortiGate VPNs with the default settings. So a known public key or a known private key can be used to log into them. So that is pretty gruesome. And we'll see how bad that turns out to be in practice. This is pretty amazing. This thing prints right on the wall. And so you can print anything you want in color and make murals on the wall. And it dries immediately. It's cured by ultraviolet while you print it. So anyway, that's pretty cool. Of course, this is time lapse. I'm sure it takes hours to go, but anyway, it does look pretty high quality and such. So that might be a fun thing to play with. And there's yet another financial scandal about Trump. And one thing that was fun here, I think this is the one that showed, yeah, there is essentially no border wall. This is one of Trump's many big lies. He keeps telling everyone he's built the wall, and in fact, he's built almost nothing, a total of 3 miles of it. It's just a fence. The ground under it is eroding. The stuff is corroding. There are gaps and holes underneath it. It's falling down immediately. And a huge amount of money has been spent to contractors to create this thing that is obviously not worth it. So it does seem like most of the money was just embezzled away, which is certainly, what we've all known about Trump is if you're a kleptocracy like Russia, where our leader is just robbing the treasury blind and putting it in his pocket and his cronies. They're just embezzling the money and pretending to do things like build the wall. Spain has got bulk phone location data to figure out where people are speeding. This is an interesting issue. You might wonder why we have traffic laws. For example, in America, nobody obeys them. They obey the red light laws, but they speed like crazy in between them. And I guess if you believe the law is perfect and you want to enforce it, you could find out where everybody's speeding and bust them there. And they're talking about it, but they can't punish you without catching you. So they can at least decide where people are speeding and perhaps take some response to it. Anyway, it certainly is true. I know if you get the Google Maps and I think other ways and stuff, it'll just tell you how fast traffic is in different areas. The same way they're just watching the physical location of a large number of cell phones. So they aggregate that data. There's been watching this in the news the last couple of days. The huge hospital chain in America has been hit by a cyber attack. Last I heard, we hadn't heard any real information from the hospital chain itself, but external agents are assuming this is ransomware. That's the most common thing. And they're having to do things by hand without computer help for several days now, as far as I can tell. All right. And of course, everybody's excited about Trump's taxes. They're probably being a big issue in the debate right now. And the fact that he paid almost no tax is sort of scandalous and annoying, but probably legal, although that remains to be seen because he used not only legal tax avoidance, tax shelters, but also probably just complete lies about his finances to do it. But what's more important is his incredible amount of debt. He owes like $400 million to largely foreign people, mostly Deutsche Bank. And that's primarily run by the Chinese. And, you know, it kind of raises an interesting issue that I hadn't thought of before, is that normally before anybody gets top secret clearance, they have to be vetted. And of course, that doesn't happen to our presidential candidates. And maybe it should. I mean, there have been some traditions where they have to divest from their financial activities and provide their tax returns and such. So there was some degree of control over the degree of corruption, but Trump didn't go along with that. So anyway, this is one issue, is that there's national security consequences of having someone deeply in debt. And especially one of the arguments I heard is perhaps we should worry more if he loses the election, because the only thing keeping him out of prison right now is the fact that he's president and can't be prosecuted. And it's coming out that the Mueller team totally could have caught him on the crimes, but they didn't dare investigate them because he would have fired them. And so they timidly didn't bother to investigate the parts he didn't want investigated, which is no way to run a criminal investigation. And so anyway, it's while he's a lame duck waiting to leave office, the only thing he's going to have to make money is to sell the American secrets and betray us even more than he already is. So we're in for exciting times, even if Trump loses. And Project Veritas is a famous fake news stunt. This guy is a right-winger, and he puts up fake videos. So now he's made fake videos claiming, trying to make the Trump claim about ballots to be true. So they're trying to claim that Omar, a member of the squad that the Republicans are constantly targeting, has got someone harvesting ballots, 300 ballots, and putting in fake ballots, which is a fantasy that Trump's been pushing a lot. So anyway, he's put out another video about that. He could resign if he loses and Pence pardon him. Yes, he could do that. And that would spare him from some federal charges, but it wouldn't stop all the state charges, and it certainly wouldn't solve his $400 million of debt. So it will be interesting to see what happens. All right, and Tulsi Gabbard's, of course, on board with this, a troubling person. So Coinbase is trying to escape political correctness. This is an interesting position to take. As you know, most companies now feel a need to at least pretend to care about the social consequences of their activities. But this Coinbase article is the CEO saying, we don't care about the political statements you want to make. This is an old-fashioned attitude from a couple decades ago. The business of business is business. We're only here to run our company. And if you want to make some kind of symbolic political gesture, our company is not about that. We want you to focus on getting your work done. And as far as saving the world, you should do that when you're not at work. And we'll see if this works. This certainly is a common idea these days. A lot of people are getting pretty fed up with political correctness and political stunts and trying to say that our business can opt out of these bigger social issues, but it is not as much true as it used to be that you could opt out of it. So we'll see what comes out of this. It does make it sound like they're trying to just write off concerns about diversity or whatever else. This led to the end of DerbyCon, the Kentucky-based security convention that went on for about 10 years, and they finally had a bunch of people complaining about how they needed to prevent people from harassing people and stuff and enforce a code of conduct. And the organizers finally said, oh, this is too much bother. Like these guys, we're just trying to do something else, and we don't want these political issues coming up, and we'll just quit rather than try to deal with them, which is an interesting issue. 10 years ago, there would have been no question. Every company would be like this, no politics at work. Now it's not that clear. Anyway, Office 365 and Azure have been out for quite a while and back and having a lot of trouble, and Microsoft's explanations have so far not explained very well what happens. They do say that it's not a hack, it was some kind of mistake made there, but I haven't heard much of a clear explanation of this yet. That's pretty dramatic. And Fox is cutting their staff, and they're primarily cutting the fact-based staff. Fox has a small group of journalists that actually report the truth and a large number of opinion journalists that just push whatever they think Trump wants them to say. They're cutting the fact-checking team because it doesn't really bring in much money. What really brings in money is the highly opinionated right-wing race-baiting conspiracy theories. That's what their primary market wants to see. And their actual serious journalists are leaving and moving elsewhere and such. So it is the #1 news source for America. And there's not much truth on there, and they're making it even less truth. So the FDA is being completely crippled by political considerations. They tried to put out a recommendation about when a vaccine would have been through enough tests to make it safe, and that's been blocked for political reasons and apparently will never be released because the decision of whether a vaccine is okay is just going to be made by political leaders, and they don't want the scientists to get in the way. So it's pretty troubling, and a lot of people say they aren't going to want to take that vaccine. So anyway, here we are. This is 126. And I didn't plan to cover a chapter tonight, and I won't. I want to talk about some more new projects. I've got quite a few new ones to talk to you about. So let me just go down here and point them out. For one thing, I put up a couple of quizzes about Ghidra. So I got Ghidra down here. There's a few projects here that you already know about where you do the simple things in Ghidra. And then the next couple of chapters, these follow the chapters in the Ghidra book. And I've added 2 quizzes to the Canvas server. Right now it's only on the City College server. I'll move them over to the other server in the next day or two. And they're extra credit quizzes because the next 2 chapters are not hands-on things. They're mostly just lists of understanding the fundamentals, but it is pretty important. In fact, let me just bring up the book here. Take me a few seconds to get it loaded. I thought this was not hands-on stuff, but it is pretty important stuff. The disassembly, navigation, and stack frames, and then manipulation with comments and stuff. So it's good to read through this. If you should get the book, which is free. And if you're interested, you do not have to do this, but I recommend it. You get to learn about the stack and the stack frames. So first, you can click labels and numbers anywhere they appear in a Ghidra display to get places, and then you can examine the stack. The stack is very, very important in understanding how code works at the assembly level. So let me see if I can get this thing to enlarge. There we go. So when you call a subroutine, there are some steps that have to go through here. And all right, here, so there are various calling conventions. So when you stop a routine and you move to the subroutine, you have to somehow store where you were originally, run the subroutine with local variables, then clean those local variables off and pick up where you left off. The standard calling convention, the most common one is the C calling convention, C tackle. And what it works is you put all the stack allocated parameters on the stack so that the first argument is on top of the stack right there. And the point of that is if you have a function with several arguments like printf, printf starts with a format string, and then you have a series of parameters to print, and you don't know how many there are. So when you enter the function, you don't know how big this data is. And this is designed for that. You push them all in the stack, you leave ESP pointing to the first one, and the called routine just finds the first one there and reads as many as it wants to off the stack. And that's designed to handle a variable amount of data. So if you have a function like this with 4 integer arguments, w, x, y, and z, it will call it. And if you call that from a calling routine with some arguments there, it will push them on in reverse order. So number 4 goes on first, then 3, 2, and 1. So 1 is right there on the stack, and that works. The calling machine can, the called routine can take care of them. And that's how it works. And the point is, when you come back, the caller has to adjust the stack pointer. So this is what you would do. You would push the arguments onto the stack, you would call the routine, and when it returns, you would then have to adjust the stack pointer. It would not do that for you in the called routine. It would be the calling routine's argument. So after you do a call and return, you cannot immediately resume where you left off. You have to adjust the stack pointer. That's how this one works. All right. The standard calling convention, which is what Microsoft uses in its libraries, is different. And it requires that the called routine knows how big the stack is. And then when you return, it can tell it how many bytes to move off the stack. So that's good. It doesn't work well for things with variable numbers of arguments, but it is the Microsoft standard. And then there's a fast call convention, which is a variation on it, where you put some of the parameters in registers and some on the stack. And then there are other ones like C++, where you're moving data structures and you move a pointer to the structure. So these are things to know, because the process of calling a routine and coming back is something you have to be able to spot in assembly. And if you take the exploit development class, we spend most of the semester exploiting this. This is the most risky activity on a computer, is the step where you return from a subroutine back to the main program, because now you're reloading data to try to pick up where you left off. And if we can trick it into reloading that data incorrectly, then we can take over the machine. So that's the main issue here. And there are some examples of this and some explanation of just where these parameters go on the stack and such. So you can read that stuff and take a quiz on it for extra credit if you like. There's not much in the way of hands-on to be done about it. And the next one, it's just talking about names and labels, which is a big issue when you're really doing hardcore disassembly of large programs. You have a lot of code and you have all these somewhat meaningless names like fun and a number and local and a number and param and a number. And after you figure out what things are, you assign your own labels, which then propagate. And there's rules here of how you do that. So that's one thing you could be doing if you want to get really good at disassembly, is doing GIDRA. But the other good stuff here is the Flare VM and an assembler CTF. So let me do them in that order. I'll start. We were already talking about the Flare VM projects, and I've added 2 more here, which are a lot of fun. Basically, this stuff is incredibly old, by the way. One of the things I've been looking for guidance is a series of blogs from 2003. It's new to me to go this much into detail, but it's not new information at all. This is x86 coding. It's been around for a long time, but it's really getting into the details of how it works. So let's take a look at some of this stuff. If you, so let me shove this to the side and get to my Flare VM. Get rid of that, and shove that out of the way. There's my Flare VM. All right. So you can make your own programs in the Flare VM, which is good, clean fun. So let me just do that. Let's get rid of all this old stuff. All right. So if you go to Start and you explore your way to Visual Studio, you got Visual C++ tools here, and I'm going to do it this way from Flare. So Flare Developer Tools, Visual C++ Build Tools, and now one of the ones you've got is the Visual C++ x86 Native Build Tools. So if you open that, you've now got a command prompt which gives you the build tools. And let me make it bigger, which is going to be font. All right. So in here, you've got tools you can use, and I'm going to go to my directory I made just to keep things under control, and then make a directory called demo and go in there. All right. So now I got a nice empty directory. So let's do Notepad. Just make a hello world. So I make a new file, and in there I can put the simplest thing possible. Just a program that, I got to use source code to get the right stuff here because it's got less thans and greater thans. I have to fix that in the project. But what I need to include is IO stream. All right. should work. Maybe I can make it a little prettier. All right, so save that. And now you can compile it. You'd use the GNU-C compiler on Linux, but on Windows, you use this thing called CL on Windows, CL/EHSC, or for just a default normal compilation of hello. All right. And see, it created a thing called hello.exe and a thing called hello.obj, which is the object in the executable. And if I run it, it's here, and it just prints out hello. So that seems like a very simple program that does almost nothing. And you might wonder, how complicated is that object in Windows? And the answer is, it is unbelievably complicated. So if you go here into PE demo hello.exe, this is the program in PE view, which is what we've been using, which is very good to get a clue how much this stuff works. So you've got, here is the raw program starting with MZ, the mark of all Windows executable, the MS-DOS header that doesn't matter. Here's where the modern PE header starts. Here's the sections: text, rdata, data, relocation, and GFIDs. And down here is assembly code. And you keep going down here and you will find readable text here. And then you'll find what look like Windows API calls. There's compare strings and such. Here's other strings used by Windows API calls. And way down here, you've got a list of all the Windows functions used by this thing. And then you've got a bunch more pointers and such that are hard to read, and this just parses it out together. So we talked about this stuff last time, the MS-DOS stuff, and here's the image NT headers, and the optional header is where you get into the part that brings in libraries. So the program will load at 400,000, the default image base, that's the normal situation. You're going to have code and data. Everything's going to be aligned to a 1,000 byte boundary. And that is going to mean you're going to have a difference between the address in this file, which they call P file, and the relative virtual address, which is the address at which it's really going to load. And down here, we got the export table is empty because this is an executable, not a DLL. So it does not offer a service to other programs, but the import table is here and the import address table is here. So you got a text section, which is the readable code. That's going to load at a relative virtual address of 1,000. So added to the base address, that'll be 40,000, 401,000 is what it looks like. It's, of course, a hexadecimal number, so it's not exactly thousands, but it looks like 401,000 where this section is going to load. Then you have rdata and data. And the rdata section is the one that matters to us most because that's what handles the import addresses. So the rdata section is here. The import address table is here. And here you see all the function calls that are required just to print hello world. And it is dozens of them. If you get into looking at the Windows event log instead of you're doing in the instant response class, you get used to this. Everything in Windows is incredibly complicated. Dozens and hundreds of events to do the simplest thing, just open a file, open a folder, and things like that. Windows is really, really very complicated. So it does all these little things inside here, and these are the function calls, and they all come from one library, kernel32.dll. So this needs to connect to one library, which is already in RAM all the time, kernel32, it's used by everything. And this program doesn't need to load any additional libraries. It just has to connect to that copy of library that's in memory. All right, so let me take a look at my instructions here and see what else I want to point out. Okay, let's talk about these addresses because that is the thing to get straight in this program. So the import table is here at a relative virtual address, and its size is there. All right, and so B2C, right. So the relative virtual address is 16B2C, okay? So remember that number, 16B2C. If I go back to the raw hexadecimal view of this, I could go down to 16B2C, And if I do that, 16B2C is here, and this is just binary gibberish, 2s and 3s. This is not the import table. And that's what I was saying. You have to get used to this sort of mind-bending stuff. The import table is supposed to be there, but that is not a P file address. P file is the location inside the portable executable file, which is sort of compressed. It has data required to build the memory sections, but it's not a one-to-one mapping of the memory sections. So in order to find out where it is, the relative virtual address of the import table is this, but you have to add that to the image base here and to the base of this segment. Now the image base is where this is all going to load in memory, and we don't need that right now, but what we do need is the base of the segment containing the imports table, which is the rdata segment. So if you look at the rdata segment, it is pointer to the raw data is FE1000, but the actual relative virtual address is 11,000. So this tells you its location in the actual binary, hello.exe, is at FE1000, but when it loads in RAM, it's going to be at 11,000. So to get from the P file address to the relative virtual address, you have to add 1200 in hexadecimal. All right. That's for things in the rdata section. So anyway, I go through the translation here. You get used to finding these various addresses. And let me move this stuff out of my way so I can see the instructions better. All right. Anyway, so let's take a look at the last bit, which is even more mind-bending, which is the way it looks in memory. So bring up Ollie debug and load this simple program in Ollie debug. So it is C and PE and demo and hello. All right, so there's the program. All right, and if I view memory, I will see the way memory is actually laid out here. And here is the hello program. Now it's loaded at a crazy address of 11C1000, not at the preferred address. So that would give me even more of a headache. And in the next one, we'll fix that, I think not in this one. But anyway, now you can see the way they're laid out. This one is at 1000. This is the start of the file at an even 10,000 in this case. Then at 1000 is here. Then at 1100 from the start comes the R data and so on. That's the 1100 layout. All right, so anyway, the import address table is here. It shows all these functions coming in. And so you've got a couple of challenges to solve here where you can fix broken files, and all you have to do is go through these steps and check the numbers and find numbers that look wrong and then patch them. So here you've got a file where you just compare to the others and find which section is missing. Here's a broken file, and here's another broken file where important things cannot be found and you'll have to fix them. These files won't even load. So that's the start at just reading this. And the next one is to go in much more detail about importing DLLs. So let me download this one. And all right, let me just put it up. It looks like there's a problem with my uploads, which I can fix. That's hello 4. Goes right here. Okay. All right. All right. See if it'll download now. That's still giving me trouble. All right, let me see. It's probably something to do with permissions. Hello 4 is there. If I go to info, nope, it's all readable. So 126 proj hello 4 is absolutely there. Let me see if it'll down. I've got another copy of my virtual machine, but you guys won't be able to do the project unless that download starts working. I might have to get rid of it in Cloudflare or something. Anyway, let's see if I can get it here. All right. Checked all these right before class, but apparently I didn't check them well enough. This is 123, and here. All right, there we go. So I can save this. And there it is in the downloads folder. All right. So I'm gonna, I guess I'll leave it there for now. All right. So let me try running it. This is a command line program. So I can do cd to downloads. All right, and hello 4. All right, all it does is print another hello message. That's all there is to it. So I want to look at this one in PE view. So let me try and clean off some of the old stuff in here. Like that one. And that one. And this one. Okay, so. All right, I want to go to my demo. I want to go, it's in downloads, hello 4. There we are, finally got it. All right, let me get back to my instructions. And there, all right. So, all right, here's the import address table, which as we've seen before, it's in the rdata import address table. So it uses a lot of DLLs. And these are all using kernel 32. So here we, all right. So I wanted to talk more about the addresses. So if you look at the rdata section itself, here, let's take a look at this one called raise exception. It is at a P file address of FF00, and what's there is 1711C. So if you look at FF00 here, FF00 is here, FF00, and here it is. This is a 32-bit value, so it is 0001171C. So that is 1171C. That is the address here. It is a 32-bit pointer to somewhere else. All right, and that is the, all right, that's, so we load into the P file, all right. And so if you were to open this file in a hex editor, we're going to use HXD and open the same file in the downloads folder, hello 4. All right. Then you can look at that location, which is FF100. Yes. All right. And I think it's not moving on me. All right. All right. So there is that address, 1171C. All right. That's a relative virtual address, and we need to find out where that goes. That is not an address I'll see here, literally in this file. To get the difference, I need to do the calculation like what we were doing before. We look at the image section header for the rdata section, which is here. And this shows us that the actual pointer to the raw data is FE100, but the relative virtual address is 11,000. So you have to add 1,200 in hexadecimal to get there. So if you go back to here, we could get there, but now I want to compare it to Ollie, and we're going to fix this one in Ollie. So let's bring this up in Ollie. Hello 4. All right, so I go to downloads and hello 4. All right, and view the memory. And so here it is. Now it's now loading at the right location, which is pretty nice. I may have, I'll probably upload a different version of this later that won't do this automatically, but this one has already been fixed with the setDLLs characteristic file. And this is a handy thing. If you, a brand new one, like the one we just made, in fact, let me just continue by demonstrating the one we just made. The one we just made was in CPE, and it did not load in its preferred address. So I'll fix this one, CPE demo. All right, if you are doing reverse, so this is a Windows feature that when you load something, if it cannot get to the preferred address, it will pick another address. And also for security, it will randomize addresses. So it loads at a crazy place like 11C0,000. But if you want everything to load in its preferred location, it makes reverse engineering easier. So we would like to downgrade this file from a modern relocatable Windows file back to an old-fashioned file that just loads in one place so we can find things. And you can do that with this thing called set DIL characteristics that you download from Didier Stevens. And when you download it, you will get a zip file called set DIL characteristics. And when you unpack it, it has an exe file and it gives you the source code and such. So all you have to do is take that exe file, it's a command line tool, copy it and put it in the same folder as the file you want to adjust, which for me is going to be CPE and demo. All right, I'm going to put a copy of that executable here just to make my life a little less confusing. So now here I am. If I go to CD to PE and then CD to demo and then dir, I've got this thing called set DIL characteristics here. So if I just run it, it will show me what it does. And here's the command I want. With -D, it will clear the dynamic base flag. So this file will no longer have address space layout randomization. Now you can see here it loaded at some crazy address, but I'm going to get rid of that with this program -D on my hello.exe. Now I can't open it right now because some of these programs lock it. So let's close Ollie, and this program in particular locks at PE view. So get them out of the way. And now that this can touch the file, it now changed the dynamic base from 1 to 0. So this file no longer relocates. So if I load it in Ollie, and okay, there it is. Is this the right one? That's the right one, hello.exe there. Now, if I view the memory map, it loads always right where it should be, at 400,000, this section at 401, this at 411, and so on. So it makes my life a little bit less confusing. And for other programs which you have, if you do a manual unpacking of a compressed file and you have to make a copy from memory, it becomes a lot handier to have files where you clean this stuff off. All right, so that's one of the tricks you use here. And you've got some more challenges here. Here are some challenges where you have to read these files and find out what is wrong with the libraries it's loading. And it will be more and more obvious. Here you just find out where it loads a library. And here's a broken file that won't run. And you will have to fix something along the path to the DLLs to make this program run. So that's the challenges there. And the last thing I want to show you tonight, which can keep you out of trouble for a long time, is again extra credit. Of course, I wrote an assembler CTF so you can practice assembly language if you really want to learn it. I haven't yet started handing this out at conferences and such because it got pretty complicated. I've got some more complicated challenges here. I actually got public key encryption working in assembler, but it was sort of insane. So let's talk a bit about the basics, and you can just do this one and submit flags and get on a scoreboard here, and those points will count in the class. So there's a series of challenges. So I just want to go through a couple of the basics here so you can actually practice writing real assembly code if you like. It's not required. This is all extra credit, but this one here you can do on any machine. You do not need that Flare VM. You can just use a Google Cloud Linux server. So let me just make a directory, a demo again. This is my Google Cloud server. And I guess I'll make my font a little bigger. Thought that would work, Shift. All right, maybe I do it up here. Control plus, Shift Control plus. All right, thought one of those would work. But that should work. All right. So let's bring up the basics here. All right, there are some things to install. Build Essential gives you compilers these operating systems no longer come with compilers built in. Multi-Lib lets you compile 32-bit code on a 64-bit machine. And NASM is the main thing we're going to use here. That is the particular assembler we're going to use. There are other assemblers, but that's a common one used on Linux. There are some subtle differences depending on the assembler you use for some of the commands. So we can make a file called hello.asm here. Get this thing to stop messing around. Listen to me. Okay. Control C, nothing happens. Okay. Oh, already got one? I thought I made a directory. I didn't go into my directory. All right, there we go. All right. Yes. There we go. All right, let me get rid of the colors so it's visible. All right, so I've got a text section and I have to have a start label, which tells it where my code starts. And so I'm going to load the registers. This is the Intel syntax. So if you have a move command, it moves the second argument into the first. And the way I always tell, because they're both types show up of Intel and AT&T syntax, and I look for a command like this, where you refer to an immediate value like 1. You can't move anything into 1. You can move things into the register, EBX, but you can't move into 1, so it must be moved the right thing into the left thing. That's what we got here. So here, I put something called len in EDX, I put something called message in ECX, then I load 1 and 4, and then I do int 80. Int 80 is the syscall. This calls the kernel, which has access to the hardware. And these parameters tell it which kernel routine to execute. And so executing kernel command 1 is right. So down here, and this is an exit, and I guess 4 is the right. Okay, anyway, this is the link to the message, and that's the message. So this is the text section. Those are going to be the assembly language commands. Here I have the data section. I can define bytes, hello world, and this way I can calculate from the current value at this point back to the start of that. It'll calculate the length of my message, which is going to be something like 10 or 12 bytes. So what this is going to do is load in this register the length, and in this register a pointer to the thing I'm printing, and then it will print it. 4 is print, and 1 is the device number, and you can find these by going to Windows syscalls to get the layout of these. This is what's actually going on when you run programs. All right, so I can save this. And now I can assemble it and load it and then run it. With these commands here, I'm going to compile it as 32-bit code. All right, and so if I run it, it prints hello world. That's all it does. All right. And so here you got an explanation, and here's a list of the system calls. 4 is syswrite, and it shows you how the registers are used. EBX, ECX, and EDX. What they've used, bringing it in here. The EAX defines which system call you're making, and the others are used for parameters. So that's the standard code to do a syswrite to 1 standard out. That's what it looks like, and that's how the data section works. So there's some theory and a tutorial you can go to practice this stuff and learn some basic theories of different kinds of layouts like loops and such, which is good. And then you can start doing challenges. You can start printing things out, like this is an HTTP request that loads the head of a web page, and you can pipe it to Netcat just so you can get a flag. You can connect to one of my servers, you write assembly code that just prints out text, and when you get the text right, you'll be able to see things, and then you can design a GET request that will get it. Here you have to define this GET request, and it can tell that you are using assembly code and not a normal browser by the user agent. The user agent in a web request determines what browser you're using, and here you're going to use this user agent, which is not a standard for any browser, but you'll be in your assembly code. And then you'll get a flag. And there's one where you get to try different usernames until you get in using a loop, and so on. There's just a series of challenges to try here. And there's more and more things to do here if you want to actually learn how to do some assembly code programming. Even down to some cryptography. I've got the simple ones here, the Caesar cipher, where you move letters forward to the alphabet, and the XOR, where you calculate an XOR with a fixed number to scramble the bits in things. And I say, I've got other ones that I haven't posted up here yet that do more advanced cryptography, but it gets to where you're writing like 3-4 pages of assembly code, and that seemed a little insane. So we'll see if enough people are interested in doing this. But that is something you might want to look into if you'd like to actually learn some assembler and practice using assembler. You don't have to do it. What we're doing in this class is very basic malware analysis where you can just look at the code and without really following it through in great detail. But if you want to move further into really using Ghidra and IDA Pro, and if you want to move into exploit development, writing your own shell code, at some point you do have to learn assembler if you're going to get advanced at that stuff. So this is an opportunity for those who are interested in getting a little deeper into it. If you don't want to do it, just skip it. You may have noticed the amount of extra credit in this class is insane. This tends to happen. I have a class, and if it's an interesting topic, I study it until it gets bigger. It's getting to be about time to fork this class into 2 classes. So in future semesters, I might have another class like a reverse engineering class with this stuff. So for this semester, it's extra. If you don't want to do all that, just do the normal stuff here. And I think that's all I wanted to show you in a somewhat organized way tonight. It's all these extra credit things you could do. I'm going to stop this video and I'll stick around to answer questions about anything you like.